Hi everyone. I know it's been a while since we've done a PowerPoint, and I appreciate your patience as the county and schools come out with their grading policy and me getting grades into PowerSchool and um, getting all that updated and ready to go. So let's continue with our exponential functions unit. And I want to take a second to compare linear and exponential functions because I think it might help you to better understand an exponential function. So, first of all, some background. You spend almost your entire time in middle school developing and leading up to the idea of linear relationships. In seventh grade, you're presented with y equals k times x, and you probably heard the vocabulary term constant of proportionality thrown around. Then in eighth grade, you're introduced to y equals mx plus b, and you call m slope or rate of change, and you're introduced to b, and you call that y-intercept or initial value. So it only makes sense that the first half of Math 1 is spent further developing the concept of a linear function. We spent our first several units on solving multi-step equations, which are linear functions. We worked on linear inequalities. We worked on systems of linear equations, all of those developing the concept of linear relationships. So it only makes sense that the second half of your Math 1 is devoted to an introduction to nonlinear relationships. And one of these relationships is exponential functions. You were just introduced to that last week. So I want to take a minute or some time really getting into the details of what is the difference between a linear and an exponential function, because like I said, I think that's going to help us understand what an exponential function is. So a linear function in slope-intercept form, y equals mx plus b. So for example, something like y equals 2x plus 0. We don't have to write the 0, but I know that my y-intercept is 0 and my slope is 2. Okay, or an exponential function, which is in the form y equals a times b to the power of x. And this is why it's called an exponential function. You have x as your exponent, okay? For example, you might have something like y equals 1 times 2 to the power of x. And we don't have to write the 1, but it's there. And when we put these functions on the graph, it's easy to see which one's linear versus exponential. So you've got your line, obviously, is linear. Okay, and then you have your curve representing your exponential function. Okay, and you'll notice that the rate of change for a linear function remains constant, whereas my rate of change is gradually getting faster and faster and faster for an exponential function. All right, so let's take a look at some more details as to the differences between linear and exponential functions. So a linear function has a constant rate of change, and you're adding or subtracting for every increase in 1x. So keep in mind, we're looking at an increase in 1x. What's happening to my y values? I'm adding 2 every time for every increase in 1x value. Okay? Whereas your exponential function changes by a common ratio. And how do you find the common ratio? How can you tell the difference? Okay, so for an exponential function, I still want to know what is my pattern, one y value to the next as x is increasing by 1. My x's are increasing by 1 every time. So what I'm going to do is divide my y value by my previous y value, 2 divided by 1 equals 2. If I divide 4 by the previous y value, 2, I still get 2. And that's going to hold true for any pair of y values. So 256, for example, divided by 128 is also 2. So 2 is my common ratio. Whereas if you take a look at your linear, you have 18 divided by 16. That does not equal the same thing as 16 divided by 14. So I know that this is not exponential. All right. So again, exponential, we have a common ratio of 2 here. We're multiplying by 2 every time. 16 times 2 is 32. 32 times 2 is 64. And then my linear function, I am adding 2 every time. That is a super important concept. Your linear functions are adding and subtracting. Your exponential functions are multiplying. All right. Determine whether the table represents a linear or exponential function. Write the equation that represents the function. So looking at an XY chart, looking at sets of ordered pairs, how do I know if it's linear or exponential? You have to decide or determine what's the pattern for the Y values. So from 8 to 4, 4 to 2, 2 to 1, 1 to 1/2, 1/2 to a fourth. And just double check always. It's a good idea just to be safe because people like to trick us. Are my X values increasing by 1? Just always double check that. They are in this case, so I don't have anything to worry about in terms of tricks. So what is my pattern here from one Y value to the next? Well, is 8 divided by 4 the same thing as 4 divided by 2? Yes, it is. They both equal 2. So that means my pattern is to multiply by 1/2. My common ratio is 1/2. I am multiplying by that fraction every single time. So if I'm multiplying by 1/2 every time, is it linear or exponential? It must be exponential because the pattern is multiplication, regardless of the fact that I'm multiplying by a fraction. All right, so B is 1/2, what I'm multiplying by. What is the initial value? Where does the function intersect the y-axis? Where does it start? It's 1. How do I know it's 1? Well, when x is 0, that corresponding y value represents my initial value. So anytime you see x being 0, that corresponding y value is your initial value. And this is a good example of an exponential decay function, just as an aside, because my rate or common ratio is a fraction. And so that's what makes it decay. When I put it on the coordinate plane, this is going to go down and down and down, faster and faster. So that's what makes it an exponential decay from left to right. Let's keep looking at some examples. All right, example after example. An art collector buys 2 paintings. The value of each painting after X years is Y dollars. The XY chart represents the first painting. And I want to write an equation to represent the function. So if I want to write an equation, I need to know what kind of equation I should write. And to know what kind of equation, I have to know if it's linear or exponential. So to know whether it's linear or exponential, I have to take a look at the pattern in the y values. But first, I'm going to check and make sure, are my x's increasing by 1 every single time? Yes, they are. So I'm good. I can take a look at my pattern in the y values from 24 to 43, 43 to 62, 62 to 81. Okay, well, I'm going to check and see if they divide to the same number. 81 divided by 62 does not equal the same thing as 62 divided by 43. You could double check that on your calculators if you don't trust me. So that means I'm not multiplying by the same number every time. So I must be adding or subtracting. Well, I'm not subtracting because my numbers are increasing. So I am adding 19 every single time from one value to the next. Okay, well, if I'm adding 19 every time, based on that fact, is the function linear or exponential? It must be linear because I'm adding. What is my rate of change? 19, I'm adding 19. What is my initial value? Well, I don't know my initial value yet, but I can use my rate of change to make predictions or work backwards. So my next value, I would add 18. Okay, so 100. Oop, nope, I don't want to end show. Okay. If that's the case, I can work backwards to figure out my starting value. What is 24 minus 19? That will tell me my previous y value of 5. So put them together and I have my equation y equals 19x plus 5, right? Y equals mx plus b. All right. And same art collector, this is the second painting. I want to write an equation. Same deal. If you want to write an equation, you got to know what kind of equation you're writing, linear versus exponential. How do I know? I take a look at my y values after double checking that my x's are in fact increasing by just 1 every time. Okay, they are. So I want to know, am I dividing? Because this process of elimination is a little bit faster than guessing and checking with adding and subtracting. So 27 divided by 9, does that equal 9 divided by 3? Yes, it does. It simplifies to 3. So that means I have a common ratio that I'm multiplying by. I am multiplying by 3 to get from one y value to the next. Okay, so I have my common ratio. I'm multiplying by 3 every time. So that must mean I'm working with an exponential function with the rate being 3. So all I need to do is figure out my initial value. All right, so similar to how we just used the linear function, we can work forwards or backwards. If I'm working forwards, I'm multiplying by 3. So 81 times 3, 243. Well, if I'm working backwards, then I would have to divide by 3. So what is 3 divided by 3? It's 1. So my initial value is the ordered pair when x is 0. So 1 is my y value. And I have my equation in the form y equals a times b to the power of x. And in this case, it's y equals 3 to the power of x. Okay, so here's my two paintings, my two equations. We've got painting 1 is linear. Oh, that's horrible. And then painting 2 is exponential. Okay, and when you're comparing linear and exponential functions, you can ask yourself some different questions. Like, so for example, which painting was worth more at the time of purchase? Well, at the time of purchase, that's time 0. 0 weeks have passed. Okay, so painting 1 is actually more expensive to start. Which painting has an increasing growth value? If you'll notice on painting 2, since it's exponential, it is growing faster and faster. That's kind of an important characteristic of exponential functions. So painting 2, which painting after how many years are the paintings the same value? So when do they have, and remember my Y value is how much they're worth. So you should notice that this is the point where they're the same, the ordered pair 481, or 481, excuse me. So after 4 years, both paintings are worth $81, after which painting 2 becomes higher value. Previously, painting 1 was the better, higher, worth more money than painting 2. So what would happen on your graph, if we're looking at the first quadrant, the linear function starts out higher, the exponential function starts out lower, but then at some point it surpasses that linear function. And this point here on the graph would be the ordered pair for 81. Okay? Now might be a good time for you to stop this PowerPoint if you are feeling a little bit overwhelmed with information and you want to just hit pause. This would be a good point to do that, because I'm going to keep going. So if we're looking at another example, let's say Lucy and Jada start a book club, and the next month they each invite 2 new members. The month after that, the 2 new members each invite 2 new members of their own, and so on and so forth. If I want to write the equation, I have to know, am I writing a linear equation or an exponential equation? Is it a linear function or an exponential function? So to do that, the only difference now is I don't already have my Y values. I've got to figure out what those Y values are because I need to know that pattern to know if it's linear or exponential. So I start out my club, just Lucy and Jada. Those 2 folks are the club. Now, next month, they each invite 2 new members. Okay, well, if this is Lucy and this is Jada, Lucy invites 2 new people and Jada invites 2 new people. Okay, so how many new people are there? 4. All right, and those 2 new members invite 2 new members. So what do we think that is? Each of these 2 new members invites 2 new members. So this person invited 2, this person invited 2, this person, and this person. Okay. And I want to, so we'll say this would be 8, 16, 32, and then 64. Okay, so that's representing how many new members there are. All right, so what is my pattern in the Y values? Is there a common ratio? If I divide 64 by 32, am I going to have the same thing as 16 divided by 8? Yes, I am. It's going to equal 2. So I'm multiplying by 2 every single time. So since I'm multiplying, I have an exponential function. what is the initial value? Okay, well, the initial value is 2 because I started out with 2 people in the club. Okay? So again, a similar example, what type of function am I dealing with? I have 50 bacteria in a dish, and the number of bacteria is tripling every day. So I start out with 50 bacteria, and that value is tripling. So my next number would be 150, 450, 1350, 4,050, and then 12,150. Okay, so what type of function am I working with? Am I working with a linear or exponential function? To determine that, I would have to take a look. Do I have a common ratio? So when I divide 150 by 50, is that equal to 450 divided by 150? It is. I've divided by 3 every time, or multiplied by 3, excuse me. It simplifies to 3. So my pattern here is multiplying by 3. All right, so if my pattern's multiplying by 3, then what type of function am I working with? I must be working with an exponential function. Y equals a times b to the x. So what is my rate? B. My rate is 3 because that's what I'm multiplying by. What is my initial value? A. What did I start off with? I take a look. When x is 0, y is 50. So my initial value is 50, and I put them together in my equation, y equals 50 times 3 to the power of x. All right, let's look at a couple more examples, and then we'll call it quits for today. So I've got a certain type of corn that grows at a rate of 3 inches per week. When the seeds were planted, they were placed 10 inches beneath the ground. So they were placed, dug a hole 10 inches deep, and I put the seeds into that hole. So if we're talking 0, this is like height above ground. And I know what's happening, but I have a trouble preventing that from happening. So height above ground is my y value. So if that's the case, then initially they are 10 inches below ground. Okay, per week. So after 1 week, the seeds are how high above the ground? Well, they grow at a rate of 3 inches per week. So I'm at -7, 7 inches below ground. I'm going to add 3. So we're 4 inches below ground. Add 3 again. 1 inch below ground. Add 3 again. And finally, we have seedlings above the ground. Okay. So what is the pattern in the x values? They are adding 3 every time. Based on that pattern, is it linear or exponential? It has to be linear because we're adding 3. So what is my rate? 3. What is my initial value? They started out 10 inches below the ground. So y equals 3x minus 10. All right. One more example. See if you can do some of this on your own. I'm going to help you get started with the XY chart. So biologist Samantha discovers to reduce soreness, people should start bicep curls at 5 pounds. So we're going to start. That's a key word there that you should look for. Start. Okay. Then progress weekly by adding 5 pounds. Okay. This is nice because it tells us literally adding 5 pounds. So I would have 10-pound weights, 15-pound, 20-pound, 25, and then 30 for my bicep curls. And you're adding 5 every single time. Why are you doing this to me? Okay. All right, so what type of function are we working with? We're working with a linear function if we're adding. What is my rate? 5. I'm adding by 5 every time. Okay, so what is the initial value? B, 5, because that's what it started at. That's how heavy you start your weights at, 5 pounds. So that results in the equation y equals 5x plus 5. Okay, guys, so we're going to spend some time practicing a little bit more with our linear versus exponential, and hopefully you understand exponential maybe a little bit better. I do want to take a look at the graphs more in depth the next time I deliver some content. So I'll be in touch.